All right, welcome. These sections are the start of a really important part of calculus, that is, of finding max and mins of things. Let's start with a picture definition. So, if you have a function that looks like this, then these points are local maxes and mins. Okay, so those three there are local minimums of the function. It means they're smaller than the people around them. Whereas these points would be local maximums. It means they're bigger than the people around them. This one is also the smallest of everyone, so that's a global minimum. And then these two are tied at being bigger than everyone else, so they are global maximums. Okay? All right. We think of these as normally always existing, but there can be problems, so they may not exist. And they don't exist mainly for two reasons. One, if you have no continuity, then you could have a function that looks like this, but the actual value is here, it's discontinuous there, and this function has no global or local maximum, because what wants to be the maximum here is missing. Another reason you can fail to have these global and local minimums is because the interval you're on is open, meaning you're missing the endpoints. For instance, say we're working on this interval here, that means that point is not included in our domain. You could have a function that kind of blows up there. When it keeps going forever, it just gets higher and higher and higher, so there is no global max, or a local one as well. So open intervals and discontinuous functions can be problems for having local and global maxes. But there's a great theorem that says if f is continuous on a closed interval a to b, then it has local and global maximums and minimums. So this is just an existence theorem. It says they're there. It doesn't tell us at all how to find them. So if you come back in a bit, we'll tell you how to start finding them. Ciao.